Backtracking can be defined as depth first search with the bounding function. The solution in a backtracking problem is expressed as n tuple, that is x1, x2, x3 or xn. The solution is obtained by searching the state space tree in a depth first manner. When we are unable to generate new nodes, we backtrack to the previous node. So basically the backtracking concept or the technique of solving the problems is based upon the depth first search. Okay, so if we understand what is the depth first search, then the backtracking is very easy. So what here we are about to is that we are about to find out the solutions, okay, for a given problem in a such a way that we start solving the problem by drawing the state space tree, by drawing the state space tree in depth first search manner. So we have to keep on drawing the state space tree from the top node to, that is root node, to the child nodes. And at a certain position, suppose if we think that we cannot generate further, means if we cannot go in depth further to a particular specific node, then what we will do is that we will backtrack to the previous node. We will backtrack to the previous node. Okay, let us try to understand this with a simple example here. Okay, here the example what I have taken is that the subjects and the preparing the timetable. We have the three subjects given to us. Okay, and we need to prepare what we need to prepare the timetable for these subjects. In this one, the three subjects are what? Java, DBMS and DAA. So here I have given the short name for those three subjects as P1, P2 and theory, TH. Okay, P1, P2 indicates that these are practical oriented subject, whereas the other one DAA is a theoretical oriented subject. Okay, this is the given problem. We need to prepare the timetable for this one. Then here, what is the bounding function? Bounding function specifies that theory subject cannot be placed in between the practical subjects. Okay, so we need to restrict our solution with respect to this particular bounding function here. Okay, so keeping in mind that these three subjects, we may have different types of solutions here. Okay, wherein we may meet the bounding functions or we may not meet the bounding functions. Okay, so with keeping in that mind, these are the different solutions what we can have here. In the first slot I can have P1, second slot P2, third slot TH. Okay, this could be one solution, that is first Java, then DBMS and then DAA. Like that we can have the remaining 5 types of solutions here. Okay, this is nothing but, okay, these are the 6 different types of solutions. But here the bounding function, what it specifies that we cannot have a theory subject in between the practical subject. Means if we have TH, that is the theory subject, between the two practical subjects, so the two here which are highlighted, these are not the valid solutions. Okay, now this is how in general we can say it, but how we can get the solution or how we can find out the solution using backtracking concept, that we are going to study or understand based upon by drawing the state space tree. Okay, now let us try to understand how to draw the state space tree here. Okay, so for the time being I have drawn the state space tree here, but I will try to trace this particular state space tree. Okay, let me write that one, state space tree. Okay, now initially what I will do is that I will mark the node 1 as the root node here. From node 1, okay, I will go in the next level as the node 2. Okay, and I will join these particular nodes, that is node 1 and node 2. So and this particular traversal or the depth first search over here, and this edge, what I will do is that I will denote it to be the P1 subject. Okay, so what it means is that in the timetable, the first hour probably I will be assigning it for the P1 subject. Okay, so what I'm trying to do here, from the first node I entered into the second node, so in the next level I am going over here. So now from this particular node, since I need to find out the solution in the depth first search manner, then what I should do is that from node 2 I should again go downwards and draw another node over here. So treating it to be a node number 3. And this node number 3, what I will do is that I will assign the time slot, that is from node number 2 to node number 3. This particular edge, I will assign it to be a subject P2. So I can have a P2 over here. I have covered P1 in the first, I have covered P2 in the second, and what I should do? Now I should again have one more node which should be to the node 3. So I will mark this to be as node number 4, and this between 3 and 4, whatever edge we have, this particular slot, we may say that the remaining subject here is TH. So I can have a TH over here as the subject. So here, first I considered P1, second I considered P2, and the third time I considered the TH. So all the three subjects I have covered over here. Are there any further subjects to be handled over here? As this particular stage, there are no more subjects to be handled. That means further to this 4 downwards, I cannot have any more nodes over here. So what I should do? I should, as the backtracking says, whenever if we are not able to draw the nodes, okay, below to the a particular node, then we should come back to the previous node. So from 4, I will come back to the previous node 3. So this particular slot is taken care already. Then from 3 to 2 slot, this I will come back. So now I will be at the node 2. Okay. So here, if you see here, TH and P2 I have taken. So from P2, instead of having the P2 as the second hour, I can have the other subject here. Okay, other subject would be what? The TH subject. So from 2 to 5, I will have one more edge, that is from 2 to 5 node I will create, and this particular slot or the edge, what I will do, I will assign it to the subject TH, that is DA subject. Okay, so in the first slot P1 is there, and then 1 to 2 is P1, then 2 to 5, now it is TH. Okay, now next, what is remaining subject here? The remaining subject is P2 now. So if I wish to have one more node over here, if I wish to have one more node down to the node number 5, then is it allowed to do so? No, we cannot have that. We cannot have one more node down to the node number 5, because we have the constraint. Constraint or the bounding function is that the theory subject cannot be placed in between the practical subjects. If I wish to have one more node here and this particular slot, if I assign it to what, say P2, then what will become? The theory will be kept between two practical subjects, which is the violation of the rules over here or the bounding function. So I cannot do it over here. So what I will do is that I will simply terminate the node over here. So what I will do, I will kill the process of creating the nodes down to this particular slot. I cannot go further beyond that. Then where I should go back? I should go now. So I should be coming back to the node number 2. I should again backtrack, which is nothing but the DFS concept. I'm coming back to the previous node. So from second node, all the possibilities I have taken care, because initially we have taken one subject, we had left out two subjects, that is P2 and TH. Both the possibilities have been taken care. Since there are no more possibilities, what I should be doing here, I should be again coming back to its previous node. So that is from node number 2 to node number 1, I will come. So in the node number 1, what I should do in the initial stages, the first possibility was subject 1 I had taken. So the next time what I will do is that I will choose subject to be the P2 subject as the first slot. So I will create one more node, that is below 1, marking it to be the node number 6, and this particular 1 to 6, what I will assign the subject as P2. Now what I should do, again I should go in the depth first manner. Again in the depth first manner means from the 6 I should be looking for some nodes which I can draw below to that one. Now here from 6 to 7 I will draw, and for this particular slot, that is the edge between 6 and 7, now I will mark it to be the TH subject. So TH subject in the sense what now? P2 I have, and the next slot I have taken it to be TH. Now is it possible for me to conduct or take one more subject in the timetable, that is after th, is it possible to have p1 over here? No, it is not possible, because if I wish to have, then what will become that the theory subject would be placed in between two practical subject. Again, that will be the violation of the bounding function. So I cannot have it over here. So what I should be doing is that I should be killing the process of drawing or the searching the nodes below to the node number 7. So then what I should do, I should again traverse back. So backtrack to the previous node. So I should be coming back to the node number 6 here. So from 6, okay, in the first 1 to 6, I have taken it to be P2, and then I tried for 6 to 7 TH, which was stopped there itself, which was killed there itself. Then I can have one more node down to the 6 as node number 8, and the 6 and 8, what I can have is that I can have it to be the P1 subject. Since in the first phase P2 I have taken, and later I tried with TH, which did not give me a solution, then I changed the solution, that is the subject, to P1 now. Okay, so P1 I can have it over here. Then from 8, I will try to draw one more node below to 8, making it to be a node number 9. And is it possible me to have a subject over here as the remaining, which is TH? Yes, I can have TH over here, because this TH, if we keep it over here, this will not violate the bounding function. Okay, this TH will not be placed in between the theory subject, in between the practical subject. So this is also one of the solution over here. So in this, that is 1, 6, 8, 9, in this particular DFS, so it will give me one of the solution to the given problem. Then after 9, what I should do? Again, I should come back to 8. From 8, again, I will come back to 6. Then from 6, again, I will come back to 1. Okay, so two possibilities from the node 1 I have tried out. Then what is the other possibility from node 1? That I can have one more node down to the node number 1 as node 10, and this node number 1 and 10, I can assign it for the subject TH. I can assign it for subject TH. That is the first class I can take it as the THO in the timetable. Okay, then from 10, I may have again two possibilities here. In the first time I can have P1. Okay, with P1 I will go now. So here I will have the node number 11. From 10 to 11 I will have one particular time slot, and this edge I will assign it to P1. Okay, I will assign it for the P1 subject. Then from 11 I will have one more 12 node which is drawn below to the 11, and this particular time slot I will assign it for P2 over here. So this will give me another solution over here, that is node 1, node 10, node 11 and node 12, in which I have TH, P1 and P2 as the subjects in the timetable. Okay, so further to this 12 downwards I cannot go. So what I should do is that I should come back to 11 and then come back to 10. Then what is the another possibility I have? I have is that I can have one more node as 13 here, and between 10 and 13, this particular edge or the time slot, I can have it for the subject P2. So P2 can be taken over here. Since if I include P2 over here, the remaining subject will be what? P1. That subject I can have as creating one more node below to the node number 13. So I will create a one more node over here as 14, and this particular edge between 13 and 14 I can assign it to be for P1. So like this way I will be getting one more solution over here, and which will be a valid solution wherein violation of the bounding function is not done. So by drawing the state space tree over here, what we have achieved is that we could able to use depth first search mechanism in order to find out the solutions for the given problem. Okay, the solutions, as I said, we get the solutions in the backtracking techniques. The solutions, it could be one of the solution or could be a many solutions. The many solutions usually we denote it or we call it as a set of solutions. The set of solutions are indicated by the terms x1, comma x2 comma x3 comma xn, could be xn. Okay, in this case we have got four set of solutions. The first solution is here is that suppose if I treat the x1 to be p1, then this is one set of the solutions. Let me highlight it with the green. This is one valid solution. Then the next one, is it a valid? No, it is not invalid. So this is also not valid solution, so I will remove these two solutions. Then the remaining other three are also the solutions over here. So like this way, by just drawing the state space tree in the form of searching the trees or creating the trees in the depth first search manner, we can find out the solutions to the given problem by restricting or maintaining to the bounding function. Okay, this is what the backtracking is here. Okay, I hope this particular concept is understood now. Are there any difficulties as of now, students? Any doubts? Okay, let us proceed further. Let us go through the next concept over here. That is, the problem is the n queens problem. Okay, so n queens problem basically is nothing but it is based upon the game of chess. Okay, it is based upon the chess game. Okay, in chess game we know one particular functionality, or that one functionality of the one of the member of the chessboard, that is queen. Okay, the movement of queen can be done in three different methods. A queen can move in a row where it is placed. Queen can move in a on a particular column. Okay, then even queen can go on a diagonal way. Okay, now in these three different positioning, the queen can be placed or can be moved in the three different positions. That is, say, assume that if a queen is over here, say queen is over here, then this particular queen can be moved on the row wise, it can be moved on the column wise, or it can even be moved on the diagonal wise. We can move it in this particular direction. Okay, now think of a chessboard, okay, or a game wherein there are n queens. Here n queens indicating means if there is a chessboard of 8 cross 8 cells, if there is a chessboard of 8 cross 8 cells, then we can have 8 queens. We can have 8 queens. Suppose if the chessboard consists of 8 cross 8 cells and then 8 queens. Okay, then assume that if a queen is over here, this is one of the queen, let me denote it to be a q1, queen 1, and suppose if I keep another queen over here, say q2, let me just maximize a little bit. Okay, yes, this should be enough. Say this is queen 1 and this is the queen 2. Now queen 1 and queen 2 are in same column. When they are in the same column, either queen 1 or a queen 2, or basically both the queens are in attacking condition. One of the queen may dismiss the other queen over here. Okay, so that is a problem here. This is the problem in the queens and queens problem. Suppose if I have one more queen over here, say if I keep a queen over here, say q3 queen, if I keep over here. Now when we look into q1 and queen, that is q3, both are in the on the same diagonal. Again, these two are what? In the attacking position. So this is also one more problem which is situated in this particular case. So basically, if we have a 8 cross 8 cells, then there will be a 8 such queens. So the solution or the problem here is that we have to identify the positions of those 8 queens in 8 cross 8, or in general n queens in n cross n cell chess game. we have to position, we have to keep the n queens in such a position that none of the queens should be in attacking position. Means none of the queens should get attacked by any other queens. So we need to find out the solutions over here. So in this particular case, the bounding functions are what? The bounding functions are three here. Those three are what? Any two queens should not be placed in same row. Any two queens should not be placed in same column, or any two queens should not be placed on the same diagonal. So we have to adhere to our bounding function here, and we have to find out the solutions for this n queens problem. In order to solve this n queens problem, since this 8 cross 8 would be a very difficult to find out, to trace it, so what we have done in the as per your syllabus is that we have taken a chess game consisting of 4 cross 4 board. Okay, we have considered it to be a 4 cross 4 board. Means what? There will be a 4 queens. There will be 4 queens. Say q1, q1, q2, q3 and q4. There are 4 queens, and we have to position, or we have to keep these 4 queens on the 4 cross 4 chessboard such that none of the queens should be in attacking position. Then how to solve this particular problem? By using the backtracking. So in backtracking, we know that we have to make use of depth first search, and we need to keep on drawing the state space tree. Okay, so now here I have already taken a graph for the state space tree over here, which is already drawn. Let me try to explain this particular state space tree over here. Okay, since in this particular case the bounding functions are what? The rows, the columns and diagonals, three are there. So what we will try to do is that we will try to have certain rules such a way that on the first row we will only keep queen 1. Okay, on the first row we will only keep, or we will assign it only for the queen 1. Then in the second row we will assign it for queen 2. Third row we will assign it for queen 3, and in the same way the fourth column we will assign it for queen 4. So if we are keeping the queens, the first queen, second queen, third queen, fourth queen on the first, second, third, fourth rows respectively, then definitely we are taking care of the first rule, that is queens will never be kept, two queens will never be kept on the same row. So that particular rule we will be taking care. Then what are the other rules we have here? Other rules are the columns and diagonals. Okay, that we have to work it out how we are going to solve that. Now in the state space tree here, as you may see, in the state space tree we have different levels over here. So this root node is there, then second set of nodes which are down to the root number 1, that is 2, 18, 34. So between these there are edges, this level 1 what we call. So over here we have taken it to be x1 values. So x1 values indicates these x1 values are explicitly for queen 1, that is q1. Suppose if I place here 1 to 2 or 1 to 18 or 1 to 34 or 1 to 50, these all values, different possible values which are we have here, these are for the x1 values. Okay, these x1 values are for what? These are for the queen 1. In the same way we have the next level. In the next level we have explicitly mentioned it for what? The x2. So this x2 belongs to queen 2. In the same way, we do have the third level, that is x3, which will be for the queen 3, and we have the x4. The x4 level, this particular level is for the queen 4, x4. Okay, then we may have different values in the x1 level. That is, x1 may have 1, x1 may have 2, x1 may have 3, or x1 may have 4. These 1, 2, 3, 4 different values for x1 indicates the column number where we are going to place it. Suppose if it is x1 is equals to 1, what it indicates is that x1. Since it is a x1 means it is the first row. In the first row, I am placing it to be a on 1, which is equals to 1 means first column. So first row, first column. Then next, here suppose if this value is there, x1 is equals to 2. So x1 means what? Again it is a first row belonging for q1, where I will be placing at the number 2. Number 2 means the column 2. So first row, second column. For example, let us take a random number over here. Random number, say this particular number 4. This between 18 and 29, this particular 4. So what this 4 value actually indicates, or the edge between 18 and 29 indicates, this is for the x2 value. X2 value means what? Queen number 2. Queen number 2 means second row. Okay, then we have the value which is equals to 4. 4 means what here? The column number. The column number 4. So Q2 would be placed at this particular position over here. The one which I have highlighted over here. Second row, fourth column. So if x2 equal to 4, that is edge between 18 and 29 belongs to this particular cell in the chessboard. Okay, suppose let us take one more random value over here. Say this one, 52 to 53. The edge between the nodes 52 and 53. So this is for what? This is for the x4. x4 means the queen number 4. Queen number 4 means the fourth row. Okay, fourth row and that particular column. I think we have taken which one? 57 and 58. Yes. If it is 57 and 58 and this edge is for what? 3. 3 indicates third column. So fourth row and third column over here. This will be the value of the other position of the queen. Okay. Now let us try to draw the or trace this particular tree over here. Okay. So you just, what I would request is that you just see to that the part which which part I'm going to explain, just focus on that particular part itself. Okay. So initially what I will do is that from node number 1 to node number 2 I will draw. Okay, whenever I say I'm drawing node number 1 to node number 2, so you should just visualize that only I'm drawing this particular edge, others edges are missing over here. Okay, so node 1 to node 2 I will draw, and since this is for x1, x1 indicates the first queen means first row. So first row, that is x1, I will be keeping at the 1 indicates the column 1. Say if I keep x1, that is q1 over here, q1 over here. Okay, then what the possibilities I will get? So from node 2 I may have the different again possibilities. So from 2 to 3 node I will draw, and this particular edge, that is between 2 and 3. So this 2 and 3 is for what purpose? It is for the x2. x2 means queen 2. Okay, so this queen 2, what I will do? Queen 2 is 2. 2 indicates what? The second column. Second row, second column. So I will be positioning it over here. Okay, now let us just try to understand the state space tree over here. Okay, so then what are the other possibilities I can have? From 3 to 4 I can have, that is 3 to 4 will be for what? x3. x3 means q3. So q3 in the third value means third column, so I will be keeping it over here. Then from 4 I can have the node number 5, and this is for x4. x4 means queen 4. Queen 4 means row number 4. Row number 4. So where I would be positioning? I would be positioning it equal to x4 is equals to 4. 4 means fourth column here. So q4 would be placed it over here. Okay. Now here we are not trying to have the final solution. I'm just showing you the how we are positioning the queens with respect to these state space tree over here. Okay, now let us try to understand whether these nodes are really possible or not. Okay, I can proceed in this particular, if I proceed in this particular procedure, that is from 1 to 2, 2 to 3, 3 to 4, 5 to 4 to 5. If I have this particular structure or the depth first search, would it give me a solution or not? We have to check it over here. So when I place 1 to 2, when I draw the line 1 to 2, that is q1, okay, it is valid. Then when I keep this second one, that is q2 over here, so is it meeting the bounding function here? Though it is not meeting the bounding function, because q1 and q2 both are on the same diagonal, which will be a violation of what? Violation of the bounding function. Both the queens will be on the attacking position, so we cannot take this particular solution, or which this particular values x1, x2, x3, x4 values as the one of the solution, because these are not meeting with the bounding function. Then how we should actually get the solutions over here? Okay, now let us try to draw those things which are only valid. Okay, now say, now let me try to use the annotation over here. Let me enable it. Okay, so initially I will start from node 1. I will start from node 1. From node 1 to node 2 I will go. So I will have it to be a x1 value. I will have it to be a q1. So q1 I can have it over here. Okay, then next, after q1, what I can do, from 2 to 3 I can go. 2 to 3 means I can have x2 as 2 value, that is this particular position. So if I keep queen 2 over here, then what will happen? q1 and q2 both will be in a attacking position. So I cannot place q2 over here. Means 2 to 3. This 2 to 3 edge I cannot have it. Then what I should do? I should come back from 3 to 2. I should now come back from 3 to 2. So 3 to 2 I will come back now. So I will be at 2 now. So what I should do now? Again, the other possibility I have to check. Other possibility means what? Since I cannot keep in the first column because q1 is already there, I try to keep it as the q2, that is in the second column. So then there will be a violation. Then what I can do? I can position it on the third column. If I try to keep on the third column, what will happen? I have to see here. Okay, now 1 second. So this will not give me a solution. This also will not give me a. Now I have to check this particular position. If I keep q2 on the third column, that is from 2 to 8. So if I choose it to be a 2 to 8, from 2 to 8 if I travel, okay, then from 8 I will be having two possibilities. The first possibility is that for the third queen I can keep it on the second column, that is if I keep second column over here. Okay, then if I keep q3 over here and q2 over here, 1 second, I think now we were q2, we had placed it over here, and suppose if we keep q3 over here, then again q2 and q3 will be in the attacking position. Then I cannot keep both of these queens like this. So what I should do again? I should try to find out the other position for q3. Other position value for q3 is what? I cannot have it on the third column because q2 is already there. So what is the remaining other value here? I can keep it over fourth column, q3 over here on the fourth column. If I keep it over here, again q2 and q3 will be in the on the same diagonal. So again it is not possible. So we try to look for node number 8 to 9, which was again violating. Then again we came back to 8, and from 8 to 11 we tried to 4. 8 to 11 means the column number 4, so we placed it at the column number 4. Then again we encountered the bounding function here, so that is q2 and q3 both are on the same diagonal, both will be in the attacking position. So I cannot keep the q3 over here. So all the positions we tried on the for the q3 and we cannot place it over here. Then what I should do? I should come back to second queen. Means I should come back to q2 over here, node number 2. Then I have to find out the other possibility. What is the other possibility for q2? is the next column. So what if I keep Q2 on the fourth column over here? Suppose if I keep Q2 over here, then what will happen? Okay, now Q1 is on the first column, Q2 is on the fourth column. Now what I need to do, I need to find out the position of Q3. Q3 I cannot keep it over here. Then what is the other value? I can keep over here, that is on the second column. So 2 to 13 I have, from 13 to 14 I can have one. So what is the value? The value is 2, second column. Second column means, suppose if I keep Q3 over here, will it become a violation as of now? No, it will not become a violation, because Q1, Q2, Q3 all are on different rows, different columns, and are not on the same diagonals. So 13 to 14 is valid now here. Now I have to look for the next queen, that is Q4. So Q4 here from 14, what I can have here, possible values. I cannot keep it over on the first column because Q1 is already there. I cannot keep it on the second column. Q3 is already there. Next column is what? Q4. That is the third column. So that is from 14 to 15. If I place at the third column, if I place it over here, then what will happen? Q3 and Q4 both will be in the attacking condition. So again it is a violation. Means I cannot keep Q4 over here. Then what is the remaining position for Q4? It is column number 4. But already on the column number 4, what I have? I have Q2. So I cannot place it over there also. Okay. So again, what I should do now? I should come back. Okay. And try to look for the previous positions. Come back means I have to come for Q2. That is for Q3. So now Q3 I have to change. Where else I can change the Q3? Now I can keep Q3 on the next column, that is over here. Okay. Now if I keep it on the third row, that is third row, third column, Q2 and Q3 will become on the same diagonal position. So what will happen here? Both will be in the attacking condition. So I cannot keep Q3 on the third column. So I should take it out. And what is the remaining position is the fourth column. Fourth column I cannot keep it because already Q2 is present over there. So what I try to do here is that I try to find out all the positions of all the four columns, and try to place Q3 over there, but none of the positions gave me the solution. So what I should do now? I should again come back or go back to the previous queen. Previous queen is what? Q2. So in Q2 also what we did, we tried to place from all the positions, possible positions, which will not give me a solution. Then again what I should do, I should again come back or go back to the previous queen. Previous queen means Q1. So I will be coming back to Q1 over here. So at this stage, what we actually done is that from 1 to 2 and 2 to 3, 8, 13, all these we validated and we couldn't find any solutions. Meaning is that whenever the Q1 is, that is queen 1 is placed on the first row and first column, we will not, or it is not possible to get the solution. Then what I should do is that I should try to change the position of the Q1. We know that we have to keep Q1 on the first row itself, but we have to now change the position of its column. So I will move it onto the second column, that is I will keep Q1 on the second column here. Means from 1 to 18 I will be having one particular edge, that is 1 and 18 I will be drawing, and x1 equal to 2 I will be denoting. X1 means it is for the Q1, that is row 1, equal to 2. 2 means the column number, second column. So I can position it over here. Then I have to look for the Q2 now. Now Q2 can be placed in different positions over here. Now what about if I place Q2 on the first column? If I keep Q2 over here, then Q1 and Q2 will become diagonal. So it is again violation. I cannot keep it on the first column. On the second column, obviously I cannot keep because both are in the same column. Then next will be what? Q, that is Q2 can be placed in the third column. Suppose if I keep it on the third column, again the violation will be there because Q1 and this is Q2. Q1 and Q2 both will be on the same column, so it is also not possible. Then what else? Where else I can keep? I can keep it on the fourth column. So Q2 I can keep it on the fourth column. So here when I place Q2 on the fourth column, Q1 and Q2 both are not on the same row, both are not in the same column, or neither they are in the same diagonal. So both the queens are safe. So this second level is taken care. Now what I should do now? In the diagram here, if it is 18 to 19 was not possible, 18 to 24 was not possible, then 18 to 29, which is number 4. Number 4 means x2 is placed, that is queen 2 is placed on the second row, fourth column, which is a safe position. So we are at 29 now, node number 29. Now, then we have to look for queen 3 and queen 4 positions. So let us first try to check queen 3 position. Queen 3 position in the sense here, suppose if I keep queen 3 on the first column, okay, would it be a valid position or not? We have to check. Okay, anyway, in this particular column, there are no queens, neither Q1 or Q2. Okay, or diagonally Q1 and Q2 are also not there. So Q1, sorry, that is Q3, if we place on the first column, that is a valid position. Means from 29 to 30, we came over here. Okay, then next we have to look for Q4. So what are the possibilities for Q4? See, suppose if we keep it on the first column, no, we cannot keep it because Q3 is already there. So the next is what? Second column. On the second column we have Q1, which is not a valid position. Then what we have here? Next is third column. So third column, if we keep Q4, then is it a safe position? Let us try to see here. Is there any other queen which is on the same row? No. Any on the same column? No. Diagonal ways, on the diagonal to Q4 there are no queens, so Q4 is a safe here. So this position is what actually? 30 to 31. 30 row node number 30 to 31 is the value 3. 3 means third column. For which particular row? That is x4. x4 means queen 4. So when queen 4, that is if queen 4 is placed on the fourth row, third column, then all the queens now we can say that are in the same positions, or the safe positions. Here x1, x2, x3 and x4 is equals to actually what? X1 is the position of the Q1's column. So Q1's column is what here? That is 2, comma. Then x2 is for Q2. So Q2 is in on which particular column? Fourth column. So it is 4, comma. Then x3. x3 is Q3's value. Q3 is in which particular column? Column number 1. So x3 will become 1. Then x4, since x4 is for the queen 4 and queen 4 is on the third column, so x4 will be 3. So when x1, x2, x3, x4 are placed on second, fourth, first and third columns respectively, assuming that x1, x2, x3, x4 are on different rows like this, then these positions will give us a one of the solutions wherein none of the queens will be in a attacking condition. So all queens will be placed on the safer zone. So this is one of the solution which we can get, okay, by drawing the state space tree. So here the state space tree, the depth search first is what? 1 to 18, 18 to 29, 29 to 30 and 30 to 31st. x1 is 1, x2 is 4, x3 is 1 and x4 is 3. So this particular path will give us a solution for 4 queens problem. Okay, like this way we have to keep on continuing in this manner and we have to find out whether are there any other solutions. Okay, so if we proceed further, we will definitely get one more solution which will be exactly mirror image of this one. Mirror image of this one means I will try to show you in the table over here. Mirror image of this means Q1 is on second column. So the other solution will be where q1 will be placed on the third column. Then q2 will be on the first column. Then for q3 it will be on the fourth column, and q4 will be on the second column. If we place again these four queens in this particular order again, then all the four queens will be safe. This is another solution. This particular solution over here in the state space tree, I will just draw it. Okay, 1 second. Okay, the first one was what? First one was this way. Second one is x1 is 3, so x1 is 3. Then x2 is 1, so x2 is 1. Okay, then x3 is 4, fourth column, so x3 is 4. Then x4 is second, x4 is second. So this is another solution, that is 1 to 34, that is 3 value. Then 34 to 35, that is 1 value. Then 35 to 38, that is 4 value. Then 38 to 39, then 2 value. This is another set of solution. So in this particular 4 queens problem, there are two different methods or the two different solutions which are valid, wherein we can keep all the 4 queens on the different positions. Is this particular concept understood, students? Now, are there any difficulties? Yes, any doubts, students? Okay, in the chart there are certain questions. Okay, if we give x1 as q1, yes, Natasha, are you on the call still?
Sir.
Hello, Natasha.
Hello, sir.
Yes, you have put a question, right? If we give
Yes, sir.
x1 as q1, what is the meaning of that? Can you just elaborate your question? Natasha?
Sir,
Yes, you can ask your question. You had put one doubt, right? What is that particular doubt?
ते x1 नाही तिथं आम्ही q1 म्हणून देऊ शकतो काय म्हणून?
Nahi. While drawing on the state space tree, the state space tree will give the values, the solutions in the form of x1, x2, x3, x4. So we have to keep it as x1, x2, x3, x4 only. We cannot say that's q1. Q1, these conventions are for our internal purpose here. So these will give us a, internally we are assuming that we are keeping q1 on the first row, which will give the value for x1. On the state space tree, always the solution values we have to keep it in the terms of x only, x1 or a x2, x3 or a x4.
Okay, sir.